Welcome to another session at GeoIgnite. We hope that you're having a wonderful time. This session called Deep Dive Building Software Solutions for Climate Change in partnership between Deploy and PCI Geomatics and Catalyst. A couple of introductions and a few house rules before we dive into the session. If you have any questions, feel free to share them in Q&A just at the bottom of your screen there, and we'll be happy to respond to them at the end of the session, and we'll be keeping track of them. My name is Hussein Bukhari. I'll be your moderator today, and with me are fantastic panel members and presenters who will be talking you through a fantastic presentation that's been put together. So without any further ado, we'll get started. So a few introductions, Justin, Pan, Jason, Peter, in that order, perhaps. Justin, go for it.
Thank you very much, Hussein. I'm Justin Mosby, R&D Innovation Manager at Deploy Solution. I focus on research activities.
Pan Panini Kantitra, I'm a software developer and the technical team lead at Deploy Solutions.
I'll go ahead, I guess, Jason. My name is Peter Hazlitt. I am a customer success manager with Catalyst, PCI Geomatics, and glad to be here.
Hello, my name is Jason Flatt, and I'm a technical solutions specialist at Catalyst. Happy to be here too.
And I'll go, I'm Nick Kellett. I'm founder and CEO of Deploy Solutions, and I'll be speaking about the first topic that we're covering today. And again, very glad to be here. So the agenda that we're going to follow is we've done the welcome and introductions. We're going to talk about the changing landscape. Then some of our research activities. We're going to talk about some of the problems building software solutions for climate change, top problems and issues of trust, belief, and willingness to act. Then we're going to cover some solutions. So on the citizen or individual facing side, on the trusted authority side, as we call them, Catalyst, our friends are going to talk about citizen science project that we're working on. And then I'm going to talk about the need for rapid application development. And we're going to leave lots of time for questions and answers. So again, if you have any, feel free to put them in the chat or in the Q&A section, which is dedicated to that. And we'll be very happy to spend some time and listen to your feedback and your questions. So let's talk a bit about the changing landscape. A bit about Deploy first. We're Canadian software developers passionate about space and the earth. We're experts in software research, development, and innovation. We develop downstream cloud-hosted solutions for the space industry, geospatial applications. We help organize the local version of the NASA International Space Apps Hackathon. And since 2019, we've been focused on individual and community research when it comes to climate change action and building software for that. And again, that's what we're going to talk about today. So we know that there's a climate change emergency. Extreme weather events are a growing concern around the world. Canada is warming at twice the world average, which is very alarming. And it's a real and urgent crisis, and it's driven by human activity, and it impacts everything. In 2019, the Canadian federal government declared a national climate emergency and a commitment to support the Paris Agreement targets. But we're hearing more and more dire news showing us that adaptation and risk mitigation are necessary for this problem. So no matter what we do, we are affected by climate change and will be increasingly so. And these are some photos that I personally happened to take in my hometown of Ottawa. This is a 100-year flood that occurred. We had 2 of those in just the space of a few years. And you can see how the Ottawa River, due to unseasonably high rain, was eroding the banks and causing all kinds of issues for downtown Ottawa and Gatineau. I also took photos in that same year of some winter storm damage that was occurring in eastern Quebec because there's no winter ice that used to form and buffer the waves. So there's more damage from storms, and this was actually sufficiently bad that it caused a tourist town, which this is Percé in eastern Quebec, to undergo millions of dollars worth of damage and renovations as a direct result of this impact. And at the same time, also another winter storm flooded a local village nearby. So these are photos I took. I'm sure that many of you are increasingly are having your own impacts that you're observing and maybe taking photos of and being affected by. So we care about this. We think that software can help. We wanted to explore that. So in 2019, we began surveying and interviewing hundreds of citizens, NGOs, scientists, and government officials to try to figure out what could be done. We identified what we wanted to focus on was what's preventing people from getting ready for these impacts. And so we identified the top communication problems, getting them to act on climate change risks. And we want to build software that will help and make it real. So I'm going to turn it over to Justin, who's going to speak about our research activities.
Justin, you're muted.
Sorry about that. Thank you very much, Nick. As Nick mentioned, we started our research activities in 2019. Overall goal is to identify ways software could overcome communication gap, and we're working on a software that gives citizens personalized help preparing for and recovering from climate change. Of course, the topic is huge, so we broke it down into smaller research projects to explore them in detail from a unique perspective. Some projects are technical and develop software and tools. Like currently, we're working with some students to help us create climate change data registry using AWS SageMaker, while also most are non-technical and focus on academic research, concepts, and design. Many projects were done by students and with our help, with our guidance, and this involves assigning them with goals and objectives, which is followed by an iterative task-based process to allow them and us to learn and adapt. The projects completed successfully have been used to build as building blocks for current citizen science work. So these are some of the example of projects I've done with students. One is designing citizen science low fidelity wireframe, which is a visual guide that represents the skeletal frameworks of the website. Also students brainstorm. Web design functionality in which citizen science can send observation to trusted authorities and receive feedback from them. The student came up with human-centered user experience, like some examples, as you can see, is having QR code for flood-prone regions. Our goal, of course, is to set up a student for success. So we give them responsibilities and opportunities to investigate, discover, and communicate and apply their learning. We also use scalable web-based communication tools like Zoom and Teams for all our project meetings. The entire learning process has been virtual, and some of the challenges we faced are like poor internet connections. For this, we've adjusted to meet the diverse need for all the students. We also provide students with project management tools to help them organize, track, and manage project delivery, such as the Asana management platform, and also document management and storage platform like Microsoft SharePoint. It is important to actively promote a diverse and inclusive environment for maximum innovation and fairness. And we've achieved this in various ways, including interviews we've conducted, and of course, the conscious effort we make when selecting the projects for the students. Other lessons we've learned working with working institution is to flexibly align some of our initial project scope and timelines with professors and institutions' goals and curriculum. These are some of the examples of projects we're currently working with students. I'll highlight a few. I'll take the first example. Recommend feature and design changes for a prototype to help with forest fires. What we're trying to ask the student here is to help us identify and recommend necessary design changes to make a flood-focused prototype. assist during or after a forest fire, because we already have a flood design in place. The second one is design a web or video tutorial to help citizen science use our web prototype. Here we're asking the students again to assist with designing a short web tutorial to help citizen scientists safely take and upload observation during or after flood. We also have several coming projects. We listed some of them here, and I'll mention one as well. Identify privacy and personal data issues relevant to our citizen science web app. We know privacy is a big issue. We need to know what privacy rules apply to us capturing and storing citizen scientists and trusted authority account and data information and history. We have so far completed 26 projects since we began our research. We have 5 ongoing and 12 upcoming projects. You can visit this on the website, on our website, which we've published this project, fight.climatechange.ca. We've had several contributors who included students, government officials, and citizens. And in 2020, we interviewed 115 Canadians, NGOs, and the 3 officials from the 3 levels of government. We also conducted 100 of surveys, and the participants were drawn from a wide demography. Some of the questions we asked included their source of climate change information and whom they trust for information when it came to climate change information. We've done projects with over 140 students in over 123 academic institutions in Canada, the USA, and Australia. And all these projects were coordinated using the RIPE experiential learning. We have what we call thanks and recognition website. Here we get to highlight the projects we've done with the students and thank them for their work. I'm now going to switch to problems, top problems. Like I mentioned earlier, as we are trying to identify the communication gaps between citizen and trusted authorities during climate change disasters, we interviewed 115 Canadians from all provinces, and they included citizens. Citizens are people who did not want to be identified in any organization, NGOs, academics, municipal government official, provincial government official, and business owners. The overall purpose of the interviews was to understand and validate the top priorities of potential problems identified as gaps and how they resonated with the respondents. We then identified problems were randomly presented to the respondents, and we asked them to rank the top 3 problems that stood out with the respondents. So number 1 problem was citizens feel overwhelmed by the volume and variety of information. The second one was citizens receive information that isn't personalized for their needs. The third one was trusted authorities have difficulty collaborating and sharing information with citizens. So we are going to do a deep dive for each problems and what the respondents said. For the first one, citizens feel overwhelmed by the volume and variety of information. This is what they said: not understanding scientific information. That is how the information was presented, explained, and the messaging. Information is too complex. We've seen reports from IPPC, or they mention reports from IPPC, which are publicly available, but it's mainly designed for government consumption. And of course, those people who are technical and can understand those kind of reports They said overwhelming volume of information. There are tons of information on climate change, some 300-page documents, which they thought was quite huge. Overwhelming emotionally, we heard of eco-anxiety and despair, conflicting information. The second problem was citizens receive information that isn't personalized for their needs. We heard from them that there's a basic knowledge gap on what action they can or must take. They lack of personalized guidance, not enough options provided, no clear channels to get help if stuck, no clear action policies at a local level, and they don't have time to act, or they have different priorities in their lives. And also they cannot afford to act on programs or no program to assist citizens. This was especially in achieving net zero. The third problem was trusted authorities have difficulty directly collaborating and sharing information with citizens. We heard of no clear communication channels between citizens and trusted authorities, lack of feedback from authorities when citizens do communicate, personnel and capacity challenge within authorities limits ability and effectiveness of communication. And this was mainly from municipalities. They explained they have budget issues, and some of them have climate change departments, others don't. Complicated scientific information not clearly communicated or understood by citizens and even policy makers. We also came across lack of trust between citizens and authorities. And the big question was who is trusted? And lastly, encouraging citizen action is not a priority of the authorities. That's all I have for you. Thank you very much.
Thank you, Justin. So let's talk a little bit about trust, belief, and willingness to act. So this is really a key element, building on the research that Justin described there. Even speaking to people about this concept we had that, there's people who have the knowledge and they want to help and they've got, authority, they're the trusted authorities. It became clear that people don't necessarily have the same understanding or trust in different groups, of course. So we needed to unpack that a little more. So one of the first things we tried to do was to come up with a trusted authority definition. And this is a work in progress, but what we came up with are that trusted authorities are individuals or organizations, and they have exceptional targeted knowledge and expertise of global warming and climate change issues, impacts, resilience, and or policy measures. So they have an understanding. And they can be reasonably expected to provide unbiased, apolitical advice. And they accept the currently available scientific understanding of global warming and climate change as described in the IPCC reports. So if these things are all present, then you would be a trusted authority. And that's a starting point upon which we explore this concept. But of course, you need to go further than that. Who is and is not trusted, and how do we get this information, and how do we provide it to people? And so we worked with students at Ontario Tech University, where they explored these concepts in more detail. At a high level, they did examine the definition. They identified the need for another role, which we hadn't anticipated, which is what they call the trusted intermediaries. So this is somebody who's not necessarily the individual or the trusted authority, but is somebody that the individual would trust to relay the information gathered from the trusted authority. So it's a third person in this triangle, or third group. They also did a lot of research on existing material that's out there, because we know that a lot of research has been done in different fields, even on matters related to trust and communication and scientific communication. And these are very complex issues, but there are fields like international diplomacy and fiduciary trust in banking and so on that look like they have some findings that will be very beneficial and help ultimately build a better solution that people could take action by having that trust in place. We also worked with some students at Utah Valley University, and they did something very interesting. They did what's called a psychographic survey, which is really not necessarily people's thoughts about something, but their feelings. And they broke this survey of Canadians into two. The first was the feelings that Canadians had about environmental conservation issues, local environmental conservation. And the second was their feelings about climate change. And what was interesting is they asked some open-ended questions. They wanted people to know how they felt about the assigned topic. So again, climate change or environmental conservation. They wanted to know how in control these Canadians who responded felt in making a positive difference for their assigned topic. What actions could they do to make a positive difference, and what tools would help them make that difference? And then they did some cluster analysis, and they analyzed the results. It was a small survey, but it raised some interesting findings. So first of all, when respondents were asked how in control they felt they were to make a positive change for either climate change, that was their assigned survey, or the other one's local environment conservation, it turns out that the climate change people really did not feel they had a lot of control, whereas the people who were asked about local environment conservation felt that they were very in control and able to take positive action. Also as well, there seemed to be a strong alignment between people in urban areas feeling they had less control in general than people in rural areas. And that's an interesting finding, because another thing that came up when describing the feelings, again, this is psychographic, this is how they felt, the feelings of local environment conservation, 21% of the words were negative. So most of the words were positive. But when people were asked about climate change, most of their words were negative. And you can kind of see that in this tag cloud, where, you know, on the left-hand side, there's, or sort of in the middle, there's environmental conservation respondents. And so there's a lot of kind of happy words and peaceful and optimist and healthy and so on. And when people were asked about climate change, they had, you know, sadness, disappointment, anger, really negative emotions. So what's interesting here is that it seems to indicate that the people who accept that climate change is real and caused by humans may actually feel far less able to take action, and they may feel very negative about this, and they may feel paralyzed by that eco-anxiety and despair. Whereas the people who are asked, you know, about environmental conservation, especially local environment conservation, they may feel very empowered to take action. And that's an interesting finding, we think, because it implies that we can reach them, even if they don't necessarily accept that climate change is real or caused by humans. Depending on the messaging, we can encourage them to take positive action if we change the frame of reference in the way that we approach this. And I think that's actually a pretty interesting finding that that we wanted to drill into further. We also asked them, you know, how likely would you be to use a website or mobile app that listed specific personal actions you could take to cope with climate change? And it seems like a large majority actually would, if they were given a tool that would help them take personal action, then they would use it. And that's very interesting, because we're going to show you some of the examples of some of the tools we think would be useful that we're building. So coming back a little bit to wrap up the, you know, issues of trust, willingness to believe, and to take action. We think that when it comes to building solutions for citizens, there's different audiences. So one is a kind of general audience that occurs before a particular disaster impact. At this point, it might be a little hypothetical or academic to the people that, you know, we're trying to communicate with. You know, maybe this is something that will affect them, maybe it isn't. They've got other things to worry about. But we think that there's an audience of people before a disaster impact that does believe in anthropogenic climate change. They accept that it exists and that it's caused by humans. And they're willing to take preparatory action, and they're willing to lead and or help others take preparatory action. I mentioned earlier that there's a large group of people who do accept anthropogenic climate change, but feel totally powerless. So we would want to move them into this category, that they're willing to take action. But then I also mentioned that there's this other group that doesn't accept that there's anthropogenic climate change. Either they don't accept that there's any climate change, or they do, but they don't think it's caused by humans. But they're still willing to act to protect their local environment, and they're willing to lead and or help others to protect their local environment. We can reach those folks, I think, and I think we should. And of course, during or after disaster impacts, you know, it's no longer theoretical, people are being affected. So now that audience is really people who are directly impacted and they're willing to take action, or they're not directly impacted, but they want to help others. So these are all different ways that we think that climate change solutions can be built, and these are the audiences that we can communicate with to get people to take action. So with all that said, that's kind of the framing for what we're about to show you, the solutions. So I'm going to turn it over to Pan to talk about solutions for citizens.
So our solution to address the problem mentioned earlier by Nick and Justin includes So the solution includes 2 web applications, so one for the citizen and one for the trusted authorities. We call it a climate change impact portal. The citizen web application is mobile friendly, so they can access it from anywhere without having to download or install anything. Its goal is to help the citizen navigate through disasters caused by climate change, view relevant scientific data, communicate with trusted authority, or voice their concerns and get involved with their community. So this works alongside a trusted authority portal, which is a desktop focused web application, which we will talk about in the next section. So the end user of these 2 applications would be any public citizen wanting to be more involved or affected by climate change, and the trusted authorities such as public safety, disaster recovery officials, government officials, scientists, academic group, and non-government organizations, urban planners, and insurance and banks. So here we have a prototype of a flood disaster in Ottawa, Gatineau. Let's start with the main menu here of the citizen focus application. From this menu, you can see we have we offer a guided checklist on what to do in the flood and related trustworthy news feed, scientific data such as water level, flood level, precipitation, and affected areas. The application also suggests related events and contacts, document uploads and storage section, insurance information. And there is a section for the citizen to report what they see on the ground as well. So this is how the checklist looks like. They could be used as a guide for the citizen to follow. There are 3 checklists in this case. These are all configurable, but the first one here is the before checklist. So this helps the citizen prepare for possible flood and how to avoid one if possible. And the during checklist is to suggest what to do during the flood to mitigate the damage. And lastly, the after list helps you guide them through the recovery process. So the user can drill down into each checklist and follow the action items. Once they complete it, they can mark it as complete. Then we would display how many actions item in the list they have completed. And as you can see on the first screen here, if you complete one of them, it's kind of red. If you complete some of them, it's yellow. And if you completed all of the checklists, it will turn into a green check mark. So next on to the map section of the application. So the map can be viewed in 2 different modes. One, the citizen who experienced a flood and need help, and 2, for the citizen or volunteers who would like to help in the disasters. So this full screen map view display multiple useful geographical related information. So for example, the location of emergency centers, hospitals, gas stations, fire stations. It also shows location of location and the impact of the flood around that area. And implemented by our sister company Terra Aura, we can also offer to display which street or parking lots are busy and suggest possible best route to evacuate. And for those who would like to help or would like to volunteer, things such as where the sandbagging regions are, or the shelters, or the food bank could be useful for them. And over here, we have a citizen science section in which the citizen can report their observation to the trusted authority. They can take photos, submit comments regarding the water level or the flood or any damage caused by the flood. And we automatically grab their locations and submit it as part of the form. And behind the scene, the trusted authority can use this information alongside along with the satellite and radar imagery to create a flat map, maybe predict possible disasters and prepare for relief facilities and warn the citizen in advance. So the last section in our citizen application demo here is the news feed. Here we filter the news related to the disaster, so the citizen could get up to date on what's going on around them easier. And this could be used as a direct communication channel between trusted authority and the citizen. So this could be where the citizen can access and like updates news from credible sources. And then we have the trusted authority portal that works hand in hand with the citizen application. So from the menu here, it looks like it's very similar to the citizen application that we just showed you. However, it focuses more on data entry and processing and communication, broadcast, and data analysis. So this is where the trusted authority can create and manage the checklist, get an insight on whether or not the citizen actually completed the checklist, and work with reports, statistics on scientific data, and publish messages or news directly to the citizen. And they could review the citizen's observation and pass them on for analysis, which we'll go into details in the next section of the presentation. And here we have a full screen map on the trusted authority side as well. It would normally contains more data, so an expanded set of data. It also allowed them to add and edit the data. Some of the layers we have here are emergency centers, sandbagging area, fire station, gas station, police station, hospital, shelters, hydro company, news station, and where the citizen observation happens. And we also include a report section that contains visualized scientific data the trusted authority can work with. So for example, in this case, we took historical precipitation data sets from weather station on the Ottawa-Gatineau region and produced a simplified visual report and also made them available for data scientists. I will pass this on to Peter to show you more about what we can do with the citizen observation data.
Thank you, Pam. Glad to be here, folks. You can go next slide, Nick. So Catalyst is a PCI Geomatics brand, and PCI is a Canadian company. We've been around since 1982. That's 4 decades of working with trusted Earth observation science. We work with over 30 partner companies worldwide to deliver science and technology to many customers in many countries worldwide. Our technology has been well used and reviewed and referenced in over 1,000 scholarly articles. We have a rich set of capabilities, and we're deeply rooted in remote sensing and Earth observation. Catalyst, the brand itself, is focused on enabling people to make better decisions faster. So we do that by delivering the Earth observation intelligence across different domains to help provide users the ability to make better business decisions and investments. Corporately, we're about making actionable Earth observation intelligence available to ensure a sustainable and manageable planet. So this project itself really falls under that overall high-level goal. You know, and some of it talking, Justin talked and Nick talked about earlier, is that collaboration problem between the citizen scientist and science and technology as a whole. I'd like to say at this point, I'd like to recognize that the project is made possible with the financial support of the Canadian Space Agency under the Smart Earth Initiative. You can go to the next slide now. So right now, government authorities, scientists, we monitor and assess impacts of natural disasters, and to a lesser extent, predict them as well, using satellite imagery, geospatial algorithms like the ones that we provide. At the same time, citizens are on the ground actually experiencing these events, possibly taking pictures, reporting observations. The goal of this using that portal that Pan showed you to upload and report observations. So the link between these two, as discussed, is not well formed right now. Citizens don't have the ability to submit those observations directly to the scientific trusted authorities. And these government authorities and data scientists generally don't have the ability to request ground truth information from these people. And we want to do that, and we want to do that because we want to be able to assess the validity of what we're doing and deliver proper information. So from a Catalyst perspective, this project is going to help define this type of framework to create this bidirectional linkage between citizen scientists and the actual science. It's going to help train and improve the flood monitoring and prediction algorithms that we use. It's going to use the ground truth data from those vetted citizen scientists to do that. As well, it's going to provide the ability for us to push back assessment packages, flood assessment packages to those scientists and let them confirm the accuracy and validate. So if you can go to the next slide. So looking a little bit at the workflow we're talking about, the citizen scientist sends their observations to the portal. Deploy is doing a great job of standardizing and validating that information that comes in and the metadata that comes with it. What we'll be able to do is take that information, that metadata, and when there's new satellite data available, we'll be able to kick off underlying workflows to use that data along with the current observations that are generated by the citizen scientists, and we'll be able to update and improve the algorithms and generate new results, delivering back information to the citizen scientist. So at this point, I'm going to transfer over to Jason, and he's going to step you a little bit through the workflow on our side in terms of what we're doing.
Wonderful, thank you. So to just go through the key concepts of this workflow. So the idea is that through the Space and Major Disasters International Charter, governments and disaster agencies are going to have access to satellite data, optical and radar. So the citizen scientist workflow will utilize both the optical and radar imagery for the generation of the flood maps provided through an object-based classification approach. And utilizing baseline data and the most recently collected imagery, these objects will be grown across the images. Image statistics will then be calculated, and each object will then be classified based upon a training model. And of course, the workflow is going to be leveraging the citizen scientist information uploaded from the portal for ground truth and for accuracy validation. And of course, the flood maps that are going to be generated will then be accessible to the public and those trusted authorities. Next slide, please. So here's just an example. So here is image radar or RCM imagery or radar imagery over the Vancouver floods that just occurred recently. Last year, and all those dark areas where you see some agricultural fields, that's all flooded. And so how can we process this? So next slide, please. So creating these objects across the imagery, these region growings, you can see all those different polygons. So each one is an object, and then we can collect underlying statistics. Next slide, please. And even provide the ground truth for the training model, and we can utilize that. So for here, we're instance identifying what is flooded and what is not flooded. So next slide. So with the training model and those attributes, we can then perform that classification and then identify what are those flooding extents over this area of interest. And this vector data can then be uploaded into the portal so that the public can visualize it, inspect it, and of course, validate it. So next slide. So the whole idea now is that once we have it accessible, the public will assess, provide validation, that will go back to the portal. And then if there's any issues or identified errors, we'll then go back to the classification system, rerunning it to then improve the results. So next slide. So what I want to talk about is the different types of data and their challenges, right? So we're working with potentially optical imagery and radar imagery. And so that itself has their own difficulties. So first of all is weather. And of course, the time of day. So during these flooding events, especially in the Vancouver data set, heavy rainfall occurring, and that can restrict the collection ability of sensors. For instance, during heavy rainfall events, significant cloud cover will prevent us from using any optical data because of the cloud imagery or the cloudy images. And then for radar, although that can pierce through the cloud cover to actually show us what is happening on the ground texture itself can also introduce some confusion in radar classification. For instance, a bare field in the springtime its return may actually look similar to a flooded field, and so you have to account for that kind of error. And of course, the return time. So if we're working with different sensors, some have longer return times than others. And so you're restricted to what kind of data you have available based on their return times. And the resolution. So some sensors have higher resolution compared to other ones. And so that will impact the results just in their accuracy and their detail for the flood maps. And the whole idea is that we're trying to work with as many data sets available, during these disasters. And so what's important is we need to then create training models specifically designed for each type of data set. So that itself provides another layer of challenges and difficulties we need to overcome. So next slide. So I want to show this is a Sentinel-2 image optical over that exact same Vancouver flooded region. And at the same date, you can see fully cloudy. And of course, with all that cloud and shadow, it introduces a level of confusion and difficulty in even identifying the flood extents because you have cloud and shadow. And of course, next slide, you can see the radar imagery underneath it. And so that's the piercing. And that's so we're restricted now for just using Sentinel-1 or other radar imagery over that area of interest because the optical images just are completely cloudy. So next slide. And that's it for me.
Thank you, Jason. So I'm going to talk briefly about rapid application development. And this isn't going to be technical, but I want to explain what the need for this is. So we know that disasters and impacts can happen with little or no warning. And each disaster impact is special in and of itself. It's dynamically unfolding. It's affecting different people in different places. It's happening for different reasons, and disasters can be compounded. They can affect each other. Again, we saw with the British Columbia flooding recently, there was also a landslide, supply chains were being cut. There was a risk of further subsequent flooding if the dikes and the flood pumps stopped working. Issues to potentially with livestock being affected, disease and all these other things. And in part, that disaster was exacerbated by the fires that had occurred in the period previously. So by definition, these are complex situations, and to be really useful, any particular solution does need to know of and be prepared for these custom requirements. The data is going to be custom, the reporting is going to be custom, the people who are interacting with it, the individuals affected and the trust authorities, they're all going to be different. And that means, unfortunately, we cannot build such a solution completely ahead of time. There's a lot of stuff that can be done, but we can't get everything done. So logically, we therefore need to deploy a custom solution for that particular disaster impact, especially. And it has to be initially available as quickly as possible. And things are going to change. So it needs to be constantly updated in terms of its functionality and its data over the course of that disaster. So what that means in practice is, with just a few hours or a few days worth of warning, an application has to be built that's really fit for that purpose. There's a concept in programming, and again, I'm not going to get technical, but it's basically the idea is when we start working with a new code or new data, we just write the words "Hello World" to the screen. And the idea is that this is our first chance to interact with the computer and get the thing to start to run, and then we can build on there. So our goal is to create the equivalent of Hello World. It's to create a working application that's helpful in a disaster in as short a time frame as we can. And we think that time frame, the goal should be 4 hours or less. That's actually a really challenging thing to do, incredibly challenging, given the complexity and the technology of everything we just talked about. But we think that's what's necessary in order to deliver a solution that's useful to the people with the timeframes that we're probably talking about. And at the same time, when you're building a solution, there are things that need to be present still, even though you're building it quickly. It has to be user-friendly. So if you're building something that people don't know how to use, especially in a disaster, that's going to be a problem. Everybody's hosting things in the cloud right now on Amazon or Microsoft, in part because it makes it easy to build things quickly. And so this would have to be cloud hosted. And again, it has to be rapidly built and deployed. It needs to be customizable because there are going to be different requirements for each particular disaster impact. There's a trend to use what's called open source code and software, and to use standards, and all of that would help to build a solution quickly because these standards are very flexible and well understood. And it has to be secure because ultimately you want people to be able to rely on this solution, and you certainly don't want it to get hacked or have some kind of problem in the middle of this disaster. There's an additional need, which is to rapidly create and import data. So data from different locations, citizen-provided data, community-provided data from NGOs, from the trusted authorities themselves. Data is going to have to flow in and out of the system, and Pan showed you some examples of the kind of visual reporting needs that are present. And again, this is part of that, that we would probably know some data ahead of time, and there's a lot of other data that we would just discover in the middle of a disaster. For instance, in recent disasters, people who go to emergency shelters are concerned about where they can leave their pets while they're in the emergency shelter. So they want to know where vets are located, or they may be concerned, they want to help out, so they want to know where the sandbags are located. This is all data that would have to be generated on the fly, couldn't be determined ahead of time. There would be data we would know about, like hospital locations and police stations and municipal infrastructure, but that's not sufficient in and of itself to help individuals and communities. So that's why this is a need, a very important need. And ultimately, we want to ensure that any such solution is easy for developers to work with, or for integration with existing systems to be done, because that's really going to make this any such solution much more effective and much quicker to build, and much easier to roll out. So we think that it also, whatever gets built, has to be developer and system integration friendly. So with all that said, I know that that's a lot to take in, but we have the opportunity to answer some questions, and I see there is already one. So if anybody has any questions, please put them in the Q&A or in the chat. And I guess we'll chat just about next steps, and then we'll answer some questions. So briefly, our next steps, we're going to continue working on this prototype that we talked about. We are working on the citizen science project. We have some scheduled projects with another 15 academic institutions, another 60 students that are unfolding. And later this year, we actually want to simulate a flood, again, maybe in the Ottawa-Gatineau region, but we want to test what we're talking about, in the real world. Obviously, it won't be a real flood, but we want to test the ability of participants to take citizen science observations, submit that to us. We want to see what kind of data we're getting, where are some of the gaps, make some fixes based on that. So we're still determining the timing of the flood simulation, but that will be later this year. And that's the work that we're doing right now. So let's turn it over to some questions. I see that there is one from Linda. So are you going to reach out to high school students to be citizen scientists and train them how to use the app? Yes, so we're working with high school students extensively. Well, I guess they tend to be college or university students, but we're working with students extensively to help us understand the implications of the citizen science project. So what are the health and safety issues of somebody taking observations in a disaster? What are the privacy issues? Justin talked about that. What is the design experience? Is this an easy application to use? Is it easy to take a photo and submit an observation? Is there a training guide needed of some kind, or a video? These are all things that the students are helping us with. As far as whether students themselves could be citizen scientists, one of the things we are trying to understand is what are the legal and safety issues with being a citizen scientist. And we don't know yet whether anybody can take an observation, or whether we need people to be, of a certain age, or meet, a certain training requirements, or whether there's sort of, safety issues associated to this that we need to consider. So that's actually a great question. And we don't know the full answer whether they themselves can be citizen scientists, but Obviously, we want to make sure that as many people as possible can be, because they'd be an important element of this solution. So thank you for asking that.
Yeah, Nick, I've got a question actually. You talked about trusted authorities. Where does the roadmap end with trusted authorities in terms of definition or non-definitional? Who does not belong into that category, and how do you kind of define that? If you can share some insights on that, that'd be very useful. And I've got another question, but I'll wait until this one's answered.
Okay, so this is a good one, and we've learned a lot over the last few years. These are very complicated issues, of course. We're talking about helping people, in the local environment with disasters and with climate change impacts. So, the issue of trust is all important, and we've seen, the consequences of misinformation, disinformation, sadly, certainly over the last little while, but it seems to be increasing almost. So when we started, we thought, hey, there are going to be individuals, they're going to want to take action, and then they're going to be what we call the trusted authorities who are just going to provide the right information for them to take. And that was way too naive. In the process of exploring this, it's clear that a lot of people, may not directly trust, government official or somebody. They may want to hear this, the information that they should be taking from somebody else that they do trust. That could be a local community leader, could be a faith leader. It could be, NGO, but there needs to be probably this, interim role that can act as a kind of an honest broker for that information. But ultimately, who is a trusted authority? Well, many of them might be emergency response officials, of course, in a disaster, but even ahead of time, what really they need to do is they want to provide information that will help the individuals in the communities either prepare or get through or respond to a disaster. That's the baseline. And they have to accept that climate change is real, and they have to try to be non-political as much as they can be about providing this information. So to us, those are kind of the major parts of that definition. And we think it's broad enough that it will encapsulate a lot of people, but it will weed out, people who want to provide, information that's wrong, misinformation, disinformation. It will weed out people who want to be, doing this for partisan gain or for political purposes. So that's kind of where we went with that definition. We're not done with it yet. I mean, there may be opportunities to revise it, but for now, that seems to be decent enough that we're able to work with that.
Great, thank you. I've got another question. Unless the audience has questions, feel free to write your questions in the Q&A tab or even in the chat. I'm monitoring them here. But in the meantime, while they write the questions, there's a level of commercialization that's happening with the overall Earth observation market, and rising number of opportunities for more data to be collected and infused with what you're doing. How does the commercial and the government aspect sort of enable you, but also prevent you from doing the things that you need to do?
Yeah, that's a great question. We're actually tackling that with the citizen science functionality right now. So first of all, the government of Canada really supports open science and open data. It's been a proponent of that for a long time. So there is a lot of information that is available through them, through their portals. As well, we're able to use some open satellite imagery, such as Jason was showing examples of their European Union or the US with NASA has satellite imagery that's available. The open data tends to be less high resolution. So without getting into it too much, for some of the work we're trying to do, we actually need higher resolution satellite imagery, for example, and that is proprietary. Arrangements can be made if this is, for not-for-profit, or this is for, disaster relief and so on. And certainly in a disaster, under the current legislation, there is the ability for government authorities to get a lot of really proprietary high resolution data very quickly. But for our purposes, as we're trying to build this and research this, it is a challenge to try to find data that is either free, but maybe not the best resolution, or to figure out how to procure data that is more expensive but has the resolution that we want. So that's really an interesting challenge. And one of the reasons we're very grateful for the Canadian Space Agency for their financial support is because they allow us to support and to explore these concepts. We also are trying to gather data from citizens. We're trying to standardize that. We're trying to gather a lot of data from municipal governments that's available. And so a lot of our work is really trying to figure out how to fuse all this data together. And it's a real challenge. And it's a challenge that the whole industry faces, as you point out. So we're kind of definitely at the edge of that wave. And it's something we struggle with on a daily basis. And sometimes it goes very well and very smoothly, and we find the data that we want, or that we get the standard that we want. And other times we're scratching our heads going, how are we going to do this, without a certain type of data that we might either not know it exists, or it's very expensive to procure. So that's definitely an interesting challenge.
That's great. Well, on the topic of, citizen, Samina's asked a question, the continuity of citizens' education is a bit problematic. Do you have a plan to ensure it?
Yes, that's a great question. So we're actually expecting to have multiple levels of citizen science contribution on a spectrum, really. And we want to include people who are, just want to help, and they haven't really thought about this too hard, and they're able to submit some observations from their phones, but they haven't gone through any kind of training. They may only be doing this once or twice, and then, that's it. That might be on one end of the spectrum that we would, classify that imagery, and if it's helpful, we'll use it. We might get a lot of those observations, so that may be a big portion of the data that we receive. On the other hand, on the other side, there'd be people who are very dedicated, and they have gone through extensive training, and we can be very confident that the observations that they're taking are very useful, and we can rely on that more heavily, but there'd probably be less of the data. So one of the concepts that we're working with right now is this idea that we would have so-called areas of interest, either set up ahead of time in a region that we think there might be a flood, or it could be set up very quickly during a flood. And those areas of interest might include an upstream, so a community upstream where people could start to observe whether the embankment is getting eroded, or whether there's some risk that's going to happen downstream in a day or two. And then within areas of interest, we can set what we're calling observation points. And so there's a thought that we could have maybe posters put up with QR codes that would have a bit of data. So as part of you observing as a citizen scientist at that observation post, maybe you take a picture of that QR code, and that shows us that you're there, provide some data. Or maybe we just say, we put a pin on a map and say, can you please go to that location and take this picture? And then we're also thinking that, people who are really interested, we could task them with observations. So we could ask them to go every few hours, twice a day, 3 times a day, So we think that there's going to be kind of a blend of observations coming at us, but that's definitely a consideration. And again, the way we're hoping to get around that is to task citizens to go to an area of interest, to go to an observation point, to take those observations that we need. And we think that they're likely to do that in their community. So if we create enough areas of interest and enough observation posts, and we involve enough people, and we make this process easy, there's at least in theory, and again, this is what the simulation would test, there's at least in theory the ability to get that continuous observation at the points that we need it, but to be determined. Great question.
Great. Yeah, I've got another one here. Is there planned obsolescence of data collected, or would they persist?
Yes, great question. So they would persist from the perspective of, as Peter and Jason pointed out, this data will be useful for training purposes, and so therefore that data would be kept, to refer back to or to use again to train the models. As far as in the middle of a disaster impact, we're still figuring out the science behind that. But we think that what we would probably want to do is set some kind of a time frame, maybe a few hours. And we don't really want to look at data older than that time frame, because it may not help to have a citizen observation from yesterday if the water's cresting right now, right? It may help. We don't know. We're still figuring this out. But it certainly wouldn't help to have observations from last year, right? But we would want those historical observations to help train the models, so that as we're processing the models, that understanding from this is what happened last year would be useful. But yes, we think that there's probably some kind of cutoff period, which we're figuring out, probably a few hours, that we would automatically filter out for the immediate response that's needed.
Great, excellent. And that kind of takes us at the top of the hour. Any closing remarks there, Nick?
No, I just want to, well, yes, there's a lot to say. There's so many people to thank, and I certainly hope I don't forget anybody, but I really like to thank the Deploy Solutions staff, for all your hard work. I'd like to thank our friends at PCI Geomatics Catalyst for your science and working with us. on here. The Canadian Space Agency, again, for its financial support of our citizen science work. All the students that we worked with, professors and their institutions, the hundreds of Canadians who have responded to surveys, the partner companies like Terra Aura Monitoring, Hussein, yourself with Astro Agency for always providing us support on this project. And again, I'm probably forgetting some people, but this is really an ongoing effort. We are bootstrapping, so as quickly as we can, apply the resources and the knowledge to advance this work, we do it. And we've come a long way in a few years, but we have a long way to go. And so if anybody's on the call who can think of ways that they can assist us or contribute to this, certainly we'd love to hear from you. And I guess that's it. I'll just end on this little slide, which is really, we all have to work together and fight climate change. And thank you very much for attending and for listening.
Great. There you heard it. Thank you for joining us, and hope you have a great rest of the conference.
Thank you.